Hello, Mr. Ryan, right?
Yeah.
Okay, so what's this problem? Do you still remember?
Splitting a number into two parts and adding them up to get the minimum sum.
Yeah, minimum sum. So we're given a number, we want to split into two parts, and we want to minimize the sum. And we have to talk about two solutions so far, right? The first solution is solve the digit. We apply this greedy strategy. We solve the digit and we start picking the digit from the smallest to the largest, right? Because we want to leave the larger digit to the right hand side, to the ones. Am I right? Yeah?
Yeah.
The time complexity for the one is O n log n because it takes the O n log n time to sort the digit if there are n digits. The second approach, we're using the bucket sorting because there are only 10 digits and we can sort the number, we can sort the digits by placing them in corresponding buckets. What I mean by putting the digit in the bucket, we just simply increment the counter for the bucket, right? And once we have 10 buckets of the counters, meaning how many digits for each bucket, then we can, what can we do? We can go through from left to the right, because the left is the leftmost the bucket is 0, right? 0, 1, 2, 3, 4, up to 9. This is it, okay? So we're just picking, yeah, we talk about it, we're picking these numbers from the smallest to the biggest, okay? So today we're going to solve this problem using this priority queue and heap. Priority queue, heap. So that's a data structure, right? Do you still remember what's a priority queue?
Is using heap.
Yeah, priority queue, what order do?
FIPO.
The queue is FIFO, priority queue is
FIPO.
FIPO.
That's what I literally said.
What does it stand for?
First in priority out.
Yeah, first in priority out. So in Python, we use this heap, right? Heapify. If we heapify, the next item to heap pop is the smallest. We can heapify the digit, and then we can just ask it heap pop. And then if there are more digits, we can heap pop again. Am I right? Yes? Because the heap pop, you give us the next smallest digit. Does it make sense? Okay, so I'm going to write the code and then tell me, you explain to me, right? Like I'm 5, okay? Define min sum. And we have this n. The digit equals list star n. S1 equals 0, S2 equals 0, heap P5, heap P5 D. Why D? Why we have digits? Why we have a digit? What do we do? So S1 equals S1 times 10 plus the integer part of heap pop D. If we still have one more digit, S2 equals S2 times 10 plus integer heap pop D. Return S1 plus S2. That's it. Okay, so let me explain it and then you tell me again, okay? Define a function, min sum, given this parameter n, which is the integer type, is a digit number. So str converted to a string, list breaking the digits, the string digit into characters, into array, a list of the characters. S1, S2. S1, S2, this is just the value, integer value of the two integer we want to split, okay? Heapify, given this parameter d, we want to heapify it, we want to make it a heap, okay? So if we want to use the heap push, heap pop, we have to heapify this the heap first, okay? By now, look, d, this is an array, we heapify it and we can use the heap pop. Okay, yd is the same thing as y there are elements in the array in the d, or y length d bigger than 0. Okay, it's the same thing. So we have digit. We still have the digit here. We have the digit. So what do? We can take the next smallest digit. S1 equals S1 times 10. Remember that if this number S1 is 1, 2, and then the next digit is 3. So S1 times 10 plus 3, okay? And after we take one digit, because we're taking two digits, digit by digit, right? So we give one digit to S1, and then we check if there are more digits to give to S2. If there are more digits, if we still have at least one digit, then we give it to S2. And we repeat this process until all the digits are taken up, heap pop, okay? The key thing is that the heap pop is taking, just like queue, right? First in priority queue. Okay, first in priority queue. The heap, you can think of it as a priority queue. First in, priority out. Okay. The first in, first out, right? The first in priority out means the priority. What's priority here? The higher priority, the smaller digit, the higher priority, right? 2 and 3, which one has the more priority?
2.
Yeah. Okay, you're listening. Okay, good. Okay, so then we take the priority out, right? And take a number with the higher priority means the lower number. Exactly. Okay, and then we repeat this process until all the numbers are taken.
Gone.
Yes. So the time complexity. Okay, if there are n digit, right? N digit. So obviously this is O(n). We need to convert it to a list. Heapify O(n). If we are building a heap out of array is O(n). Right? But if we are building a heap by pushing heap push an element n times, that's O(n) log n. Okay, that's the difference. Okay, now heap pop is log n. So look, we are taking n digit until all the digits are taken. So the time complexity is O(n) log n, right? Because here is O(n) and here is log n. So O(n) log n. Okay? Yes? Okay, so these are the three approaches. And obviously there are more, like we can brute force, right? Yeah? How many ways we can split into two digits? There are a lot, right? It's not trivial to write a brute force. Am I right? Yeah, you can brute force using the depth search, breadth search. We can find the different ways of splitting this number into two. This is not the most elegant, most optimal solution. There are three approaches. The first one, sort the digit, which is greedy. The second approach, bucket sorting.
Which is greedy.
Greedy. Yeah. The second approach, it's also the greedy. Okay. The third approach, using the priority queue. Okay. Okay. So what have you learned today?
We learned about using heap and what we learned last time, which was yesterday, I think.
Okay. So what's
And we're using heap this time.
Okay.
Which is FIFO, first in, priority out.
Okay. So what's this function doing? Heapify. What does it do?
Sort it.
It make it a heap. In English, Y5 something like that. What does it do?
Make it.
Make it. Yeah. So it basically make it a heap. This is what it means. So D originally is an array, a list. We are making it a heap. Because when we're making a heap, we can use the heap push or heap pop, right? Heap push is push the element to the heap, and then in the meantime, the heap will be maintained, right? The structure will be maintained, so we can heap pop again. So heap pop is taking the next element with the higher priority, which is the smaller one. Okay, yeah. And there's also heap replace. Can you guess what heap replace? Just guess what does it do?
Replaces all the priority numbers.
Oh no. Heap replace is basically heap pop and heap push. Okay? So we take one out and we push another in, okay? Heap pop. Okay, so
That's replacing.
yeah, let's replace it. Yes. Okay, so these are the three approaches. I believe we covered it all. Which one is the optimum? The first one is the O(n) log n. The third one is O(n) log n. The second one is O(n), right? Because bucket sorting. So which one is better? Which one is not optimal? It's the second one. Okay.
You always leave the second one to last.
No, not always. Right? Sometimes, not always. Okay.
And also, it's most different. Is different to the rest. So why would two be the most when it's only just gonna be one? No, it's not a question. I'm just saying. Two of them are O login and one of them is Owen. It's obviously going to be O because why would two of them be the fastest when you said which is the fastest? So it must be only one of them. And
Yeah, I didn't say that. Okay, but that's a good point. Yes. There could be two solutions which are equally the best, right? I didn't say that.
Yeah, that means they're not the best.
Okay.
It's just the same.
Yeah. That's
Okay.
near the top.
Equally the best, right? In English, you can say they are equally the
Yeah, but
best,
you
right?
don't-
Like Eric, Ryan, you are equally the best, okay?
Yeah, but you didn't say equally. So ha ha.
Okay.
Ha ha. Ha ha. Ha ha.
Okay, that's it for today. Bye bye.